example, we're looking at the points of inflection as well as the regions of positive and negative concavity for this function. Well, we see that we might have to apply the product rule, which is okay, just a separate principle we're applying to this general method. So second derivative, let's take the first derivative. Product rule, derivative of the first term, e to the x, times the second term, plus derivative of the second term, 2x, times the first term. And this reduces down to e to the x times x squared plus 2x. Now we do have to take a second derivative, so it may be easier to just leave it in this form. So then we can apply a power rule or a product rule directly instead of a chain rule. So let's just leave it in this form and take the second derivative. Let's use red for our second derivative. Well, product rule again. So we already took the derivative of this, so we know that the derivative of this simply equals this right here. The derivative of this equals this. So then we can just say e to the x, x squared plus 2x e to the x. Well, then we must do the derivative of this term right here. So another power rule, or another product rule, excuse me, derivative of the first term times the second plus derivative of the second term times the first term. So now we have this simplified e to the x times x squared plus 2x plus 2x plus 2 x squared plus 4x plus 2. So to set this equal to 0, we can find the points of inflection and then examine for concavity. So e to the x equals 0. E to the x cannot equal 0. So x squared plus 4x plus 2 equals 0. Well, we're just going to have to use the quadratic formula because we can't factor this out. So let's use quadratic formula. Or you can plug this into your calculator and solve for it. And we get x equals positive and negative square root of 2 minus 2. So that is our point of inflection. Well, let's examine what happens there. So we have 5 divisions this time. One being negative root 2 minus 2, positive root 2 minus 2. And we have x between negative 2 root 2 and positive 2 root 2 minus 2. So then x greater than root 2 minus 2 and x less than negative root 2 minus 2. So plug in arbitrary values to find the behavior of this function. So when x is less than this value, which we can use a very large negative number to examine it, we'll find that is going to be positive. So a very large negative number squared is a very large positive number minus a smaller negative number. We're still going to be positive. So positive, and then in between negative root 2 minus 2 and positive root 2 minus 2, plug in an arbitrary value, and we'll find that the second derivative is negative. And same for the bigger numbers, it's going to be positive. So here we have your 2 points of inflection. And here we have the corresponding concave up, concave down, and concave up regions. So the second derivative test is very similar to the first derivative test, but it's important to not get confused when using either. We might have to know the difference between them. The first derivative test is testing increase and decrease of the function, while the second derivative test observes the concavity nature of the function. So thanks for watching Educator.com. We'll see you in the next lesson.